Hello. This is our study titled Analysis of Surficial Sediment Grain Size Data in Tampa Bay, Florida by Jimmy Bailey, Ben Galbraith, and me, Owen Roberge. And I'm going to tell you a little bit about the introduction of this poster. This study compares data sets from 3 publications that collected sediment cores from 1984 to 2006. The cores were collected throughout Tampa Bay, which is a marine estuary located on the Gulf Coast of Florida. The bay is a shallow, sediment-starved, drowned river valley with an average depth of 4 meters, excluding dredge shipping channels. And in our research, we plan to determine a correlation between anthropogenic development and sediment finding trends due to the fact that grain size is a function of physical energy. And as anthropogenic development shows tidal current energy, grain size finding trends are a result of that. Within the 22-year span of the study, there has been a lot of anthropogenic development in Tampa Bay, including the reconstruction of the Skyway Bridge, which was completed in 1987. And in the study, our hypothesis states that a direct relationship between physical energy and sediment grain size shows that historical changes in physical energy can be understood through sediment analysis. And as a result, grain size trends are indicative of changes in tidal energy due to anthropogenic development in Tampa Bay.
Cool. So now I'm going to talk a little bit about methodology and some of the results that we found. So overall, we took 437 sediment samples from, as Owen said, 3 different studies, some from the USGS, other from Dr. Brooks here at Eckerd College. These surficial sediments were collected via vibrocore, ponar grab poles, hand sampling, and scuba diving. In the vibrocores, we took the topmost layer and studied that versus the entire core. The sediments were then dried, analyzed using the sieve and pipette method to obtain the phi values. From there, the data was aggregated from spiral-bound books, online files, and USGS web pages, and we placed that into a master Excel sheet, which we then took the data and split up into 3 geographic regions. As you can see in figures 1, 2, and 4, these regions were Lower Bay, which extends from the Skyway Bridge westward out towards the Gulf of Mexico, Middle Bay, which is from the Skyway to MacDill Air Force Base there, and then from MacDill Air Force Base up north is what we divided into the Upper Bay. These 3 regions were just geographic and helped to divide things up over time. And then after that, we averaged the phi values, calculated them, and graphed it against time to show how the grain sizes change year to year. So some of the results, as you can see in tables 1 and figure 3, show that over time the data formed sort of a bell curve shape. 1984 and 85 data was the most strongly correlated to each other. They were only 0.3 feet across the board away from each other. After 1985, the values diverge, and then in 2002 and 2004 are the most apparent swings in phi value. From there on, it gets a little bit closer up until the last year, 2006. And then from there, the phi values get closer, and in some years, as in 2005, we didn't have data for the Middle Bay. However, as you can see, we can extrapolate the data from there. Jimmy?
So the biggest takeaway from this study is that before there was a lot of anthropogenic development in and around Tampa Bay in the 1985-1984 samples, it was fairly stable. And then past that, we see a growing trend of unstableness in the grain size, and thus by relation, the depositional methods, and thus by association, tidal currents, which are the main forms of sediment distribution and deposition in Tampa Bay. And so the main takeaway from this is that more research is needed, specifically in the gaps in our data between 1985 and 1992, and between 1992 and 2002. There are large gaps in our data, and more data should be continued to be collected throughout the future. Thank you so much to everyone listening, and a special thanks to Dr. Greg Brooks for supplying us with the 1980s data and the 1990s data. Thank you.
Thank you.